This concept of entropy, which is something I first heard about at thermodynamics class, sophomore year, one of the hardest classes, but most rewarding I ever took. But that is this concept that things are constantly decaying or slowly losing order. And over time, that means that everything we know that is in order, that gives us meaning, is going to be destroyed.
Yes.
But you also look at entropy in a different way. I mean,
well, I look at it that way, plus something else. There's a subtle quality to entropy that we often don't emphasize when we're just talking in general terms, and what you described is a perfect description. I would have said something quite similar in describing entropy. But when things disintegrate, when order tends to go to disorder, and disorder overall tends to grow in the universe, that does not rule out the possibility that pockets of order can form, so long as when they form, they eject enough disorder to their surroundings so that overall the total disorder goes up, even though a certain amount of order forms in the process. I like to call this the entropic two-step. It's kind of a dance. Entropy goes down here so long as it goes up by a compensating amount over here. Down here, up there. And that dance allows for orderly things to happen in the universe. That's why you have stars. It's why you have planets. Otherwise, if entropy everywhere always went up, those particles that came out of the Big Bang, they'd just keep on going their merry way and would never clump back together into stars and planets. There would be nothing.
Okay, but in the long enough timeline, everything decays.
Yeah.
And you said even protons, which just, it hurts me when you say that. Because like, for some reason, ever since you all studied the protons and electrons, they seem like these things that never go away.
Yeah.
It's this, well, at the time thought smallest piece of matter, I guess it's not true anymore, but it seems like this thing that's never going anywhere.
Yeah, and I think we hanker for that. I think that we humans...
We love permanence. I'll love you forever.
Yeah, we want things to be chiseled in stone. We want things to last forever. And my belief is that that comes from our singular recognition that we are not permanent as individuals. We are mortal. And that recognition that we are all going to die gives us a certain amount of focus on things that will outlast, that will live on forever. And for a while, and it could still be, people thought the proton would be a particle that would last forever. But our cutting-edge theories, not yet confirmed, and I make this clear in the book, but our cutting-edge theories suggest strongly that protons themselves die. They disintegrate into finer constituents. And probably, according to our math, it happens, say, roughly around floor 38 of the Empire State Building. So it's in the far future. We're at floor 10 now, and it's exponentially high to go even to floor 38. Every floor, you're going a factor of 10 longer. But that will happen. And on these timescales, complex matter itself will fall apart into finer ingredients. And so everything that we know about will ultimately disintegrate.
And then is it over from 38 up, or can I go up to the 100th floor?
Well,
and will there be another big bang or something else?
It could be. Well, there are interesting things that happen along the way. For instance, at floor 50, something interesting happens, which is if there are any cogitating beings left in the world, you might say, how could there be any if there's no protons, right?
Yeah.
But I'm being more general. I'm imagining somehow maybe a collection of electrons sending signals to each other can somehow have some conscious awareness. Let's just allow that to be as general as possible. You can argue that roughly floor 50 is a time when any such being will think its final thought, because thought itself is a physical process that yields entropy, heat. The universe needs to absorb that entropy, but you can argue that the universe will be chock full of entropy by that point. It won't be able to absorb the heat generated by that thinking being, so one more thought, and that thinking being will fry up in the entropic waste produced by its own process of thinking. So thought itself has a limited life expectancy in the universe, and from there, black holes are the one remaining thing in the universe. There was a time when we thought they were permanent, but then Stephen Hawking came along and showed us that black holes give off radiation. It's called Hawking radiation. They are not completely black because of that, when you take quantum physics into account, and they give off radiation and they get smaller and smaller, and ultimately they are gone into this bath of particles. So by the peak of the Empire State Building, it's a good number, roughly 10 to the 100 years into the future, black holes themselves will be gone.
And then that's it.
Almost.
Really.
It's
Almost.
pretty much, it's it for any time scale that you could
Okay.
really imagine. But if you're going to go wild, and toward the end of the book, I allow the mathematics, it's free reign into the arbitrarily far future. Particles in the void, on occasion, can just slam into each other and stick together in groups of 2 and 3 and so forth, and then over fantastically long time scales, can build structures over again. They can recreate protons and recreate atoms, and one of the weirdest things that they can recreate is a human brain. They can come together to create a brain floating in the void. It's called a Boltzmann brain, and that brain floating in the void, if its particulate arrangement happened to match mine right now, would think it's having this conversation, even though it's floating out there in the darkness of space, has no history, thinks it has a history because memories are just patterns of particles in the brain, but it would just spontaneously appear out of the particles in the void.